I'm David Fowler.
And I'm Stefan Halter.
We're going to talk about what's new in SignalR in .NET Core 3.0. All right, so here's our agenda. We're going to start off by doing a small version of what is SignalR, a 101 for those of you who aren't familiar with the platform. We'll talk about our new NPM organization. So we made a small change to where we store the package in 3.0, and that's important. We'll talk about the new feature client to server and server to client stream. It's a pretty cool feature that we have a demo for in 3.0. The most sought after feature in SignalR has been reconnects. If you've used SignalR before, you know it's a source of pain. So in 3.0, we have a new feature called automatic reconnect, and we have a demo for that as well. That Stefan will show in a few seconds. If you're familiar with .NET Core 3.0, we have a feature called server-side Blazor, which is powered by SignalR as well. And finally, if you want to scale your application in Azure, use the Azure SignalR service. All right, so what is SignalR? SignalR is a client. We call it a persistent connection abstraction. What that really means is any place you want to use WebSockets or get live updates, you could use SignalR instead. It's an abstraction because we have multiple transports backing the actual connection. It can be long polling, server-sent events, or WebSockets.
So why not just always use WebSockets?
Some clients aren't capable of doing WebSockets, so depending on your client and service capabilities, you may have to downgrade to different transports. So let's talk about how each of those work before we go into a quick demo of how SignalR works. So for long polling, the client sends a request to the server side saying, do you have data? And the server will respond after some amount of time with, I have data or I don't have data. The reason it's called long polling is because that poll could last for up to a minute without getting data. And the server will or won't reply with data. And then after the server replies, the client sends a new request asking for more information.
So this is better than regular polling.
Better than, yeah, it's better than asking every second, but it is still not as efficient as other transports. So server sent events, or SSE for short, is an API in the browser where you send a request using an event source API. It's long-running request, and the server can send responses over that single request. So it's really good for server-to-client throughput, but it's not great for client-to-server. That still requires a request per message. And then the big kahuna is WebSockets. So you send a single request that says, I want to upgrade this connection to WebSockets. And then the server says, OK, cool, let's change protocols. And now we have a single connection that goes server-client, client-server over the whole lifetime of the connection.
Do I have to pick which one I want to use?
SignalR is smart enough to pick the best transport based on your server and client capabilities. We call that process negotiation. Now we're going to do my classic favorite SignalR 101, which is the chat program. So in case you want to do, replace Slack or Microsoft Teams, here's your in. So we're going to start with having a file new project. Here's my Hello World project so far. I already prepared, since we don't have much time in this demo. So I used the new client-side package manager to add SignalR. So I can go to, sorry, that was kind of fast. Show it again. Right-click the project file, add client-side library.
So this is new.
This is new in VS 16 point, I don't know the version, 16
All
point
right.
something. And I can choose a bunch of different providers. So there's CDN.js, a popular CDN library manager for JavaScript packages. I can get it from disk. I can use JSDeliver or unpackage. Unpackage mirrors packages in a CDN-like format from NPM. So I can use it to search for example, Microsoft SignalR.
So it's not at ASP.NET SignalR.
It's not. And that was our old organization. We wanted to be where the other packages for Microsoft were, so we went to the same org. And you can see here, Microsoft Slash has a bunch of packages. And I can search for SignalR. And if the internet is willing, it will work like a charm. But if it isn't, I already prepared the application because I knew this could happen. All right, so that works, trust me.
Normally you would see like the files, and you could select which ones you want from the NPM package.
So quick segue, this is the older version of the package. It's under ASP.NET/SignalR. And the version is 1.14. Going forward, it is under Microsoft/SignalR. And it was published 15, well, I should refresh, but probably today, right, at some point. So for 3.0 and onwards, you want to use the Microsoft org on NPM. We didn't deprecate the old because we still have people using the old package. We haven't figured out what to do there yet. So that's the current state of the world. All right, so that was not interesting. So I added the package. Here I have Microsoft SignalR disk browser. and a bunch of files, a map file, a min file, the typical things you see for a client-side application. And on the server side, I'm going to wire up SignalR now. So I'm going to wire up my already built chat hub. I actually have a copy pasta, because I'm lazy, the endpoint. So there's a new feature in ASP.NET Core 3 called endpoint routing. And I'm going to wire up SignalR to those routes. This is different from 2.0, where we had an app.use SignalR. There was a middleware for SignalR in the pipeline. App.use SignalR is still there, but it's deprecated now. You see it? Can you see that? Is that zoom in?
It's in the tooltip, deprecated. For those who can't see the small text.
Yeah, I was zoom in, but I don't want to risk it. So now it's, instead of calling use SignalR, you do use endpoints, map, hub, chat. So I'm mapping the chat hub to the chat endpoint. I'll hit F12 to see the actual hub. The hub is very simple. The hub is where all the clients connect to. It's the central hub on the server side. There's a public method called send. And what send does is send will send to every client that's connected. It's all because I'm sending to every single client. And I'm calling this send method, passing the message that was sent to me. So I'm kind of an echo broadcast to all clients. On the JavaScript side, I have a simple page here that has some pretty fancy UI, a text box, a button, and a UL for messages. This is the height of my UI skills.
Not even Bootstrap?
Not even Bootstrap.
Wow.
And I have a clean area here to write some code from scratch. Boom.
Wow, that was fast.
Yeah. So let's go through the code very quickly. I'm creating a hub connection builder, passing in the URL/chat, what we had on the server side. Whenever someone calls send from server to client, it will call this function, and then it will create a new entry in the list of messages.
I see it's not case sensitive, is it?
It is not, because that would be user hostile. All right. Now we use vanilla.js, the library, to wire up the event. So whenever someone clicks on the send button, I'll add an event listener. Whoa.
Whoa.
IntelliSense. I'll add the click handler to get the text from the text box and then send it to the server side. So calling invoke here ends up calling invoke passing in send is calling the send method. Right, those map. Let's run this. I hope it works the first time. All right, to demo SignalR, I need at least 2 people. Otherwise, it's kind of boring talking to myself in the same window. So I'll talk to myself in a different window. So hello. Yay. Works. All right. All good.
Cool.
Working fine. All right, it's working right. Good. Awesome. All right, so that was your SignalR 101. If you want to get started to make a Slack competitor or Teams competitor, that's how you get started. All right, let's continue from there. That was a quick demo, I hope. Let's talk about how SignalR broadcasts to different groups of clients. Just now we did a broadcast. So going to everyone currently on the hub. You can also go to a single user, and the user may have more than one device. So I'm David. I may have well, we have Anthony here, so let's use Anthony. Anthony has a desktop, an iPad, or a tablet, or a Surface, maybe a Surface, and a phone. And we can target all of those devices, or we can target a single device. Or we can target arbitrary groups. So imagine you had a chat application that had chat rooms. A group could be a different chat room. So I can send to everyone, to a user, to a connection, or to a group.
So one client can be in a bunch of groups, right?
That's right. So I can be in 2 chat rooms. I can be in many groups. Now Stefan will show us his super awesome Uber demo that shows pretty much all the new features. No pressure, Stefan.
Yeah, thanks, David.
No pressure.
So since David showed you the sample that you all already saw, I was tasked with creating a new sample. So one of the big new features in client-to-server is client-to-server streaming in SignalR 3.0. So we have another Visual Studio instance, which is a SignalR 3.0 sensor demo. So to show you what client-to-server streaming looks like, we're going to have a C# client. So this uses a SignalR client very similar to the JavaScript one that David just showed you in the chat sample. But instead of showing you chat and allowing you to chat, what this is doing is this is publishing sensor data to the server. So because I'm on David's computer right here and we are short on time, I'm going to have to describe this part of the demo to you because I don't trust myself to type it accurately. But you have what you saw before, Hub Connection Builder. And in this case, it's connecting to a sensor hub. Just like on the JavaScript client, we have this builder pattern. So you create a Hub Connection Builder. Pay no attention to the man behind the curtain.
What's that region?
All right, it's actually not that complicated, but we're not doing anything too tricky. We're just trying to have a no-op callback.
Hide it, hide it.
Yep, sorry, should have skipped it. So after we start it, this quickly goes into using our client-to-server streaming ability. So you'll notice that we have a single method call. So in this case, we're calling a hub method called publish sensor data, and then we're passing as an argument an iasync enumerable. So this is kind of new. It's in .NET 3, and then we also have async iterator support in C#8. So this is pretty cool. What it allows you to do is this every second is creating a new async enumerable item to double from 0 to 10, and then it publishes it to the server.
Very cool.
Unlike a regular IEnumerable where you might call like enumerable get next and it's going to block an entire thread, this is all async, and so it's very scalable.
What is the await using var?
Ooh.
Some new syntax there. Is that
That's a good catch.
C#8?
Yeah. So our hub connection implements iasync disposable.
Oh, very cool.
So not only do we have a using that's scoped to the method, so that means that it gets disposed when the method ends. Since it's await using, it's calling dispose async. So that allows us to, without blocking, without wasting thread pool threads, shut down our hub connections.
We hate blocking threads.
Yes, especially in ASP.NET. So if you ever have like .result or something, try to figure out how to do less of that. So we can quickly take a look at what this is doing on the server when we call publish sensor data. We're using another C#8 feature, which is await for each. So we can take this iasync enumerable, you just saw us pass it, so it gets nicely serialized, deserialized in real time as new data arrives, and we can asynchronously iterate over it. So again, like this await for each is basically calling enumerator move next async, it's very efficient, and then we can use our sensor collection service. So if you go and look at our startup class here, this is just like we call add SignalR. We have this service here that basically allows us to publish our sensor data, and then we can subscribe to it using get sensor data. So I can show how you can stream server to client. So this was already a feature in SignalR 2x, but you can combine these together nicely. So inside of our web app, we are going to have this chart, which is going to show us the sensor data. And we're going to use streaming to download the stream. So here we have this chart div in our body, and we're going to use new, I think it's ES6, async await, and we're going to update this object of like XYZ sensor data. So again, hub connection builder, connect to the same sensor hub, and then after we await and start the connection, we try to see like what are all the sensors that are connected to our web app. Once we get, this is an array of strings, all of our sensor names, we call subscribe to sensor for each sensor, called get sensor data. And then this is returning like an RxJS observable. We didn't pull in the RxJS library. If you did, you have a lot of cool helper things to do like filtering and things like that. But what we're worried about here mostly is every time we get a new sensor, piece of sensor data, we're just updating this object. And that's going to ultimately update a line chart. And one last thing is, you'll see that this subscribe to sensor, we're calling connection.stream instead of like connection.invoke or something. So this is like, when you're doing server to client streaming, you call that stream API. And then this is returning the same iasync enumerable that we published. So without further ado, we're going to control F5 this. And we're going to quickly see a browser pop up without any sensors. But fortunately, we already have the folder where we had that program CS, where we have that async iterator that's giving us random numbers from 0 to 10 every time. So we're going to run sensor with a name X, because we're using the first argument as the name of our sensor. And we're going to run a sensor with name Y. We can call the sensor whatever we want. As long as it's X, Y, Z, it should end up showing up on this chart. And we can go full screen here, because this is one of the few SignalR demos that doesn't really need side-by-side. If it was side-by-side, all the browsers would be seeing the exact same sensor data.
What is that data?
It's random doubles from 0 to 10. So
it's like an earthquake chart.
yeah, it's pretty
Seismograph.
fancy. That sensor is kind of getting crazy, but it was really simple to write. So that was my favorite part of it. that was pretty short. So what happens now, though? Like, actually, there's a slide for this. It's going to be like the one time, like in practice, I missed it every time. So we just did server to client streaming as well. But what happens if the connection ... breaks? And there are a lot of reasons this could happen. You could have some mobile client going through a tunnel. You could be redeploying your web app. The quick way for us to sample it here is just to close the server. We can pretend we're redeploying. If we go back to our app, you'll see we're no longer getting new data because the server shut down. And if we were to restart the server with Control F5, nothing's going to reconnect. So people who might be used to previous versions of SignalR might expect this graph to start moving again. But SignalR Core, up until 3.0, had no way to automatically reconnect. We told customers that write a closed event handler,
Do it yourself.
start the connection manually. But that ends up being a lot of code. And I don't know about you, but when I write a lot of code, it's like more likely that I'm going to write a bug. So after, like you said, it was highly requested, we added some automatic reconnect functionality. And this part I'm going to try to kind of write. So let's see if we can pull it off. Hopefully it's simple enough that I'll be able to do it. So to make the sensor automatically reconnect, we go into our hub connection builder, and anywhere you want, like with URL, it's like, you can chain it. We can call with automatic reconnect.
Why is it not on by default?
So we're worried about making breaking changes. We don't want people who expect the client to disconnect to suddenly, after they upgrade to SignalR 3.0, just start reconnecting without them realizing anything's going on. So you have to specifically opt into this, but we try to make it as easy as possible. So we have this with automatic reconnect extension method. We're going to use the default overload, which will try to reconnect as soon as the connection goes away, and then we'll try again after a few delays. If you want to control the delays, you can pass in your own array of time spans, or if you want even further control, you can look up retry policy on MSDN. So we would like it if that was the only thing you had to do. But there's one or two gotchas when reconnecting. One thing you'll notice is like after we connected here initially, we called publish sensor data. As soon as you reconnect, any ongoing method calls end. So what this means is that you need to, if you want to continue publish sensor data, you need to call that method again. So this part, I am going to write an on reconnected handler. So what this is hub connection now has a reconnected event. So if you use with automatic reconnect, it will call this once the client successfully reconnects. And it's exactly what we did after we called start async. We just call publish sensor data with our async iterator. And that should be enough to have the sensors automatically reconnect. Now we have to do something very similar in JavaScript. So again, to save me some typing, we're going to just pass in with auto reconnect. We're going to use that method on the hub connection builder. And with the client, with the chart client, we ended up having many streams. So we called get sensor data for each sensor. So there were two that we just used. So for each of those sensors, we're going to want to call get sensor data again when we reconnect. So JavaScript also has a reconnect event. It's a very similar pattern. And just like we did after we connected, we can call get sensor names, and then for each of them, subscribe again. One thing that you'll notice, I kind of glossed over this really quickly in the C# client, is that we actually pass in a connection ID every time you reconnect. What this is indicating to the user, because you can actually, if you want to, go hub connection.connection ID, and it will be the same value. So it's not strictly necessary, but it's more like we're trying to highlight that this is a brand new connection from the perspective of a server. So onConnect is going to be called again. You've got to resubscribe to any groups that you want to be called. You need to start all your methods. The one big thing that you don't have to do, again, is you don't have to resubscribe to any on callbacks. So now that we've enabled, whoops, let's not fail the demo. Yeah, let's not break it. That's all you need. That should be everything to do reconnect.
Magic reliable SignalR connections that last forever.
Right. And one thing you'll notice is we only made client changes to do this, right? So we can leave the server running once we get it running again. So then we now have to restart the .NET clients because they stopped because we didn't have automatic reconnect earlier. Now we do. And I'm going to make sure they're both stopped so they don't get in trouble when they're recompiling or whatever. So we're going to start our X sensor. We're going to start our Y sensor. And so far, it's what you saw before. So nothing too surprising. But the question is, what happens when the connection is lost?
When the earthquake hits.
Right. So right now, we have 3 SignalR clients connected to our web app. We have both sensors, and then we have this web page that's showing us the data. And they all have ongoing streaming calls, client to server, server to client, and they all need to restart. So we close it, cross your fingers.
Stops. It flatlines. Everything's dead.
Yeah, all right, we control F5 again. Don't pay attention to the new tab, because obviously that's gonna work, but apparently the sensor's reconnected. And okay, it's still flatlining. There might be a delay, hopefully. There's a delay as it's trying to reconnect. I'm suspecting that we're in a 20-second delay right now.
Really?
Yeah. We can hit F12 and we can see some of the logs from this. Did we refresh this? Did I save? That would be
Did you
funny
refresh
too.
it? Did you refresh that old page with the new?
All right, so normally we would try to be seeing reconnect events. So let's look at this again. All right, so that's just the favicon. That's the only error. So this should have auto reconnect because I saved. So we're going to do this one more time. If it doesn't work, we're going to pretend.
This worked before.
Yeah. So you can see the sensors are trying to reconnect. That's what those logs were. And then boom! So now you can see it went from flat line to the lines are moving again. I don't know if you can see the screen.
We killed the clients and the client's flatlined.
Yeah.
It's kind of a visceral.
All right, so now we're going to go back to David to talk about the SignalR service.
Let's see, we've got a little bit of time left to talk about the service. All right, so you finish your application and you want to deploy it to Azure now. And the issue with that is that you need to scale both long-running connections and short-lived connections in the same application. So what the service was designed to offload your concurrent connections to a different service so your app can scale the web traffic independently. There's a free tier in the service. You can get up to 20 connections. And you can pay for more scale if you want up to 100,000 connections. And in 3.0, we actually improved the experience where you add a package and you add a single line of code to do so. Before it was 2, now it's 1. So huge improvement.
2 is too difficult.
Yeah. So before, in the olden days of hosting SignalR, you would host everything in an app service or an AKS cluster, and you would put your pages and your hub in the same application. All good, all good and fine. The issue is you're trying to scale the long-running connections in the same app as your short-lived connections, and that can get kind of tricky, right? So the SignalR service, you add it, and what happens is it moves the SignalR traffic off to the server side, and then your app can batch channel connections over a different pipe than the actual ingress traffic. So you're turning 1,000 connections into 5, as an example. And I'm going to turn Stefan's demo into a connected SignalR service application with just a single line of code. One line of code. Okay.
Are you sure it's only one line?
Maybe.
Like,
hopefully.
are you going to like git stash pop and hide some stuff?
So the first thing you do is you install this package that I installed previously. It's going to be RTM today. People have to wake up on a different side of the world to upload a new package. So I have Microsoft Azure SignalR 1.1.0 preview, blah, 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 blah. It'll change to something else eventually. I think 1.1.0 RTM will ship today. And then in my startup class, I can do add SignalR, add Azure SignalR. I'm done. That's the whole thing. That's the whole thing.
So how do we prove that it works?
OK, so
what is the service doing even, actually?
Web scale.
Web scale, OK. Independent scaling.
Yeah, still works, right?
All right.
So that's all good. And
Whoa, did our client just reconnect?
It did reconnect. If you look at the log, it started off at, should I zoom into that? Key plus, is that work? Look at that, look at that. It started at localhost 5,000 sensors, and it went offline, came back online, and ended up going to SignalR hello service, SignalR service, client, hub, blah, blah, more things.
So you had a web app and 2 sensors that were connected to localhost.
Yep.
You typed in .add Azure SignalR, redeployed, and then everything just kept on working using the service.
Yeah, magic. So it's going from my client to Azure, back to my machine, which is super inefficient because it's like, it should be both in Azure, but it's a good demo.
But if they're both in Azure, it's way more efficient.
Way more efficient.
And you don't have to like scale up your Azure App Service just because you have like 10,000 concurrent connections.
Exactly. And actually, I believe the conference is using the Azure SignalR service to show notifications on the actual stuff below this video, right? So
that's what I heard.
That's pretty cool. Awesome. So I believe we have to take questions soon or something. That's the thing. It's the whole thing. Maybe. Are you ready, Scott?
Hello. It's live television, people. We're trying to raise a lot of money for the kids here.
Sorry.
That's okay. So a couple of questions, and one of the questions I've actually had, and there's at least 3 or 4 different examples of this on Twitter, or people are saying they want to understand if they're using Blazor and WebAssembly, how do they call SignalR? Are they using, because they're in WebAssembly, they're on the client side, are they using the .NET SignalR client? Are they using JavaScript? One person was even so sassy as to say, I challenge you to do this in Blazor without using JavaScript. So what's the relationship between Blazor, WebAssembly, SignalR, WebSockets, Go.
Super interesting question. So
That you have no doubt thought about deeply and in the past.
we have.
Architecture and plan.
So there are multiple. So currently today, I believe there's a third-party SignalR client written with JS interop to make a .NET-based client that talks to the JavaScript-based client to make an end-to-end scenario work, right? That's what we don't want to ship that. We actually want to ship the full .NET client as it is today running on my machine, compiled into, well, I guess interpreted in the browser. The only thing that we would shim is WebSockets. So you shim the transport layers. So you need to shim HTTP client and WebSockets to use, fetch or WebSockets in the browser. But the actual C# logic from the client should run in the browser like a normal C# library. But
Not yet.
But not yet.
So far
it doesn't run, and you have to kind of use JS interop to talk to the JavaScript SignalR client from C#, which feels kind of insane because you're going like C# interpreted, calling to JavaScript to do stuff, and then getting events back to C#, and then like the whole end-to-end.
So what would you recommend to people today
Right
as
now?
we release .NET 3.0
Yeah.
who are enthusiastic about Blazor because you've
About
got Blazor
WebAssembly
client
or
side,
server
you've got
side?
Blazor server side, you've got SignalR. They are excited, but they don't know what the correct way to go is.
So for server side, the situation is a little bit unfortunate because it's not very efficient. You could use the C# client, but what will end up happening is you will spend an entire connection, TCP connection, per client, per browser client. You'd have one per server. Well, one WebSocket client on the server side per browser client, which isn't super efficient.
Right. So right now, server-side Blazor uses SignalR to kind of bridge the server and the client.
Yeah.
But adding extra connections between the server and the client is a little unnecessary.
Yeah.
So we're looking at ways to optimize.
So
that.
today it's inefficient, and you can use the client on the server side, but it's not great. That plan, we're going to solve that, I think, like before we ship 5.0.
Okay.
Yeah.
So there will be guidance and prescription on how to do that.
Of course.
Okay. Another question. Here's an interesting one. So with SignalR, help understand how Kestrel would work. If you were just doing Kestrel, and can Kestrel talk SignalR and handle lots and lots of connections, or do you need to have Azure or IIS or something big in front of it?
No, so Kestrel works fine. It's actually probably more efficient than all the other servers that we have for SignalR, and it can handle a ton of concurrent connections. We're not the best at memory, but we actually made a ton of improvements in 3.0 for connections over WebSockets to reduce memory footprint and improve throughput.
And there is a Redis, horizontal scaling, so you can scale that way. But I would say like how many connections are supported will depend on the activity of the connection. Oftentimes, you're bandwidth limited with these SignalR applications.
And memory.
Memory, yeah. It depends, but like those broadcast scenarios can easily consume a lot of
CPU.
yeah.
Yep.
Here's an interesting one. With the new focus on gRPC.
I was waiting for this one.
Are there plans to have SignalR work with gRPC streams? What is that relationship?
Very early.
What is gRPC streams for those of us who might not know?
So it's funny. So gRPC supports streaming.
Is it funny, David?
It's pretty hilarious.
Funny,
I knew
haha?
it was gonna happen. Funny, like uncomfortable. Okay, not.
No, but what is gRPC streams?
gRPC supports streaming from client to server and server to
I believe so.
and server to
Using
client. It supports
HTTP
both
streams.
directions. They piggyback on top of HTTP request, which is interesting. And it pretty much looks just like the feature of SignalR, except ours is a little bit nicer because we were kind of like we use async and removal on both sides, so it kind of looks more native. But the feature set is pretty much the same feature set between both things.
Except for SignalR, of course, also provides the pub sub kind of groups and broadcasts and things like that.
Yeah.
All right.
So there is overlap, but there's no current thinking around merging the two features.
Maybe that's a conversation that you might want to have on Twitter. I would encourage everyone to
public.
go to Twitter and crush @DavidFowle and friends with questions about SignalR, because he has nothing better to do today than answer these questions. And I want you to go ahead and just absolutely flood him. Thank you very much, David and Stefan.